Welcome, Matrix. So nice that you joined us today. And to those of you that haven't joined us before, and this is your first time, welcome to Watobe. Yeah, I'm seeing lots of names I haven't seen before, but some people that we have, Swelihle, Atinkosi, Isaiah, Timothy. Nice to have you with us again. Thank you for joining us. Yeah, and of course, and if this is your first time, welcome. Cool. All right, so guys, same as with the session on Monday, this is a workshop about the fundamental counting principle. So that's obviously what we're going to be focusing on. I hope that you've got a pen. Hi, Christian. Nice to have you here. I hope you've got a pen and a calculator and a book to write in. Oh, yeah, and did I say calculator? You need a calculator as well. So that's fine. Please get started on the do now. This is something that everybody should be able to answer. And we'll just wait a couple of minutes and everyone will be in, and then we'll get going. And of course, hi to anybody who's watching our live stream. Hope that you enjoy our lesson as well. And I will try and provide opportunities where you can also participate or vote or, yeah, jump in wherever you can. Okay. All right, guys. So I know it says example 1, but you're going to answer this question. It really shouldn't take you more than 2 seconds, 2 minutes. Okay, Matrix, so if you've been able to answer the do now question, please can you pop a thumbs up into the chat for me, please? So yes, if you've done the do now, please put a thumbs up into the chat. Cool, thanks, Atinkosi. Just one person? Only one person been able to do it? I really need you guys to communicate with me and tell me where you're at. If you don't understand or if there's things that you are stuck with, thanks, Christian. You need to tell me so that I can either explain it better or try something else, because this has got to be useful to you. So only 2 people have responded. Okay, Daneo, cool beans, thank you. All right, so the first person who said yes was Atinkosi. Can you tell me what you got as your answer, Atinkosi? Are you willing to share that with us, please? Silindile, you also did it. Thank you. What did you get, Atinkosi? Even if it's wrong, nobody's judging you. We're all here to learn. What did you get? Okay, I don't know, Atinkosi, maybe you're not willing to share your answer with me. That's fine. Daneo, are you willing to share your answer? What did you get?
Ma'am, I literally got a lot of meals that could be made up. It's like over 1,000 with like only one meat, fish, chicken, everything. So I
Oh,
just didn't
wow,
want to be giving
Atinkosi,
the
you
wrong
are
answers.
amazing. Wow, that's pretty cool. All right. Never mind. Thank you so much for unmuting your mic and talking to me. That's not a problem. All right. So part of the reason why I put this question here as the do now is because the answer that you get to this really tells me quite a lot. It tells me whether you understand the basics of the fundamental counting principle or whether you don't, which is why I was quite keen for people to sort of share their answers with me. Okay, so Danilo got, okay, wow, cool. Danilo, explain to me how you managed to get 362880. What did you do, Danilo?
Ma'am, I counted the number of meals, and then I found out that it was like 9 from choice 1 to choice 2. So then I said 9 factorial on my calculator. That's how I got the answer.
Oh, okay. All right. That's
Yes,
fine.
ma'am.
Okay. So now that you've explained that to me, at least now I can understand where you're at. Okay. So unfortunately, thanks to Nao, thank you. But unfortunately, Atinkosi's answer was wrong. And unfortunately, so is yours to know. But that's fine. That's why we're here tonight. And it's funny actually, because this is where I think maths, we kind of tend to overthink things. You know what I mean? We think, oh, it must be so much more complicated than what it first appears, and it's actually not. So would you believe that the answer to this question is 15? The answer is 15, guys. Okay, because there are 3 ways. Okay, so meat, fish, or chicken. So we've got 3 ways in which we can use choice number 1, multiplied by 1, 2, 3, 4, 5 ways in which we can use choice number 2. So that gives us a total of 15 different meals. How easy was that? Is there anybody who was thinking 15 but just didn't want to say it? Please explain that again. Okay, all right. Benedict, what we are doing is that we are counting the number of possible meal combinations that can be. Timothy, you were thinking 18. Okay, you might have to tell me why. But it explains it quite nicely over here. There's 15 different choices, okay? So Benedict and everybody else, there are 3 possible choices in choice number 1, followed for 5 possible choices in choice number 2. Okay, so these are the kinds of meals that can be made. You can have meat and mash, and fish and mash, and chicken and mash. Or you can have meat and chips, fish and chips, and chicken and chips. Or you can have meat and baked potato, fish baked potato, chicken baked potato. Or you could have meat and rice, fish and rice, chicken and rice. Or you could have meat and vegetables, fish and vegetables, chicken and vegetables. But of course, we don't want to have to write all of that out every single time, because that's going to take us forever. All right. So that's why we multiply the number of choices that we have in one way of choosing something by the number of choices that we have in another. All right. So it's simply a matter of saying, well, I've got 3 ways in which I can choose the first item. So either meat or fish or chicken. And I have 5 ways in which I can choose the second. All right, so that would be 3 by 5 different meals that could possibly be made up. Okay, what do you guys think of that? Does it make sense? Is it a lot simpler than what you thought? Timothy, I was thinking 2 options times by 9 meals. Okay, so what you're doing, Timothy, is that you've got to multiply the number of ways in which one thing can happen by the number of ways in which something else can happen. That is our rule. Okay, we're going to practice it again, and there's going to be another example here that we can do. All right. In fact, I tell you what, why don't we go to that and then we can come back to this one. All right. So for now, everybody, just ignore question number 2 and let's just have a look at question number 1. Okay. So we have got a party pack of 3 items. Okay. So here in the middle of the screen, we've got 3 items that we can make a party pack from. Okay. 3 choices. Okay. So choice number 1, we can either have Smarties, Astros, Jelly Tots, or wine gums. In option number 2, we can have Coke, Fanta, Sprite, ginger beer, or cream soda. And our third choice is a donut, a Chelsea bun, and a cheese roll. What you may have found, Matrix, is that your teacher has showed you how to do this by filling blocks. This is what I always do with my Matrix when I start off teaching this section. So in other words, just get the pen. Okay, the total number of choices is made by how many of choice 1 multiplied by how many of choice 2 multiplied, whoopsie, that's not a multiply, that's a plus, that doesn't help us, multiplied by how many in choice 3. Okay, that's the total number of choices. All right, so if I want to fill the first block here is for choice number 1. In how many ways can choice number 1 happen? So Benedict, you tell me, how many options do I have for choice 1?
4.
4, exactly, perfect. So either you've got Smarties, or correct, Celindida, or you can have Astros or Jelly Tots or wine gums. Fabulous, brilliant. Okay, so there are 4 options for choice 1. How many options do we have for choice number 2 now? Let's ask Dineo. Dineo says 5. Good, Dineo. Coke, Fanta, Sprite, ginger beer, cream soda. Cool, that certainly is 5. Great, you guys are getting the hang of this. Lovely. And then the last one, how many options do we have over there? Christian, would you like to give us an answer? How many ways can we choose the third item? In 3 ways. Beautiful, wonderful, good job. Okay, so the total number of different party packs that can be made is going to be 4 by 5 by 3. So that's 20 times 3, which means we could make 60 different packs. Thumbs up, thumbs down. How are you feeling? Please pop something in the chat for me. You understand? Feeling a little bit better? Good. Okay. Cool, guys. Please, at any time, if you don't understand anything that I've said, you are more than welcome to stop me, and then we'll go back over it again. Okay, I really don't mind. This is why we're here. Okay, no question is a stupid question. Your matric finals are just around the corner, so I want this to be as useful and as beneficial to you as possible. Okay, so let's go and have a look at this example now. Let's consider the word park town. So you are required to form different 8-letter word arrangements using the letters of the word park town. An example of a word arrangement would be the word, but now that's not actually a word, is it? I mean, APKROTWN is not actually a real English word. This arrangement of letters need not make any sense. How many possible word arrangements can be made? First of all, question A, if the letters may be repeated. Okay, so now I'm putting this question out to Rekhomoditswe. What do you think? How many possible word arrangements can we make if we're allowed to repeat letters? Are you not sure? Do you need help? Even if it's wrong, guys, seriously, it doesn't matter. If you just try. No one's going to be upset with you. No one's judging you. You're not sure. That's fine. Okay. 64 arrangements, Christian says. Good. It's unfortunately not correct, Christian, but it's a good attempt, all right? And I can understand where you got the 64 from. You said 8 times 8, which there's just one tiny little mistake that you made. Okay, so Asipe, tell me, where did you get 40? Oh, wow. 8. Aha. Okay, cool. So there's loads of answers coming up, all right? Now, where's my calculator? Swelihle, you've got that right. Look at everybody, look at Swelihle's answer, guys. She said 8 to the power of 8. Now, I don't know if that's the same as what Chido said and what Benedict said. What's 8 to the power of 8? Cool, yes, it is. Okay, so there we go. All right. At Nkosi, you only got 10. Fine, we're going to talk about why. All right, so Benedict, perfect. Okay, you got the right idea. Swelihle, right idea. Chido, right idea. Okay, very good. Everybody else, don't stress. This is why you're here. We are filling 8 boxes, Matrix. Okay, we are filling 8 boxes. Okay, because there are 8 letters in this word. So 1, 2, 3, 4, 5, 6, 7. Woo, what kind of box is that? 8. All right. Because I am allowed to repeat the letters, it means that if I've used a P here, I can use a P again. And I could use the P again and again and again and again and again and again. So essentially, I've got 8 letters and they can each go into the blocks. There's no restriction. So what that means for me is that I've got 8 ways in which I can fill the first block. I've got 8 ways in which I can fill the second block. I've got 8 ways because I'm allowed to repeat my letters. The 3rd, the 4th, the 5th, the 6th, the 7th, and the 8th, because repetition is allowed. So that's where the others got 8 to the power of 8 from. Okay, does that make sense? And that's this huge big number, 1, 6, 777, 216. Okay, so because we are allowed to repeat, we are using exponential notation. How does that feel? So the guys that didn't get it right, how do you feel now? Thumbs up, thumbs down, where are you at? Okay, cool. All right. We're feeling got it. Okay, beautiful. All right. Now check out the next question. All right. The next one says the letters may not be repeated. So again, I think the best way for you to answer this question, Matrix, is to think about how you are going to fill these boxes. Let's just move this stuff down. Okay, how are we going to fill these boxes? Again, we've got 8 boxes we want to fill. Oh, there we go. Yes. Nice. Okay, well done. All right, good Christian, good Benedict, good Daneo, good Chido. Beautiful. All right, so 8 factorial. All right, so here the answer is 8 factorial, which in this case is 40320. All right, so do we actually understand what 8 factorial means? Yes, Atan Corsi, 8 factorial. Okay, so 8 factorial, there we go. Someone said it. Who was that? Let me look. Christian. Okay, perfect. All right. So Alyssa, you said you don't understand. That's fine. I'm going to explain it to you. Okay. So others, just hang on a second, because there's just a couple of people that don't understand what 8 factorial means. All right. So we've got to be very clear between the difference between 8 to the power of 8 and 8 factorial. So when we say factorial in maths, the symbol that we use is an exclamation mark. And what that means is that we are going to start with the number 8, and then we are going to multiply by 7. So 1 less each time, then by 6, then by 5, then by 4, then by 3, then by 2, then by 1. Okay, so that is what 8 factorial means. All right, the reason why we would use 8 factorial to answer this question is because the letters may not be repeated. I can fill the first box in 8 ways, but once I have used that letter, I'm not allowed to use the letter anymore, which leaves me with only 7 letters for my second choice, and 6 letters in my third box, and 5 letters in my fourth box, etc., etc. Okay, so very important, guys. When things are allowed to be repeated, that is when you can use exponential notation. If repetition is not allowed, you've got to be thinking factorial. Okay. All right, let's go on to the next thing. All right, here was a question for you. Okay, so based on the conversation we've just had, let me just rub this out, because that's what we were talking about just now. All right, I would like you guys to try question number 2. Based on the conversation that we've just had, try number 2 in the middle of the page. We've already done number 1. All right, so consider the word Florida. You're required to form 7 different letter word arrangements using the letters of the word Florida. It's a pleasure, Olusola, no problem. In A, how many possible word arrangements if the letters can be repeated, and if they can't be repeated, I'll give you 2 minutes and then you can tell me what you think the answers should be. Indeed, Timothy, good, well done. Okay, nice one, Timothy. Okay, so Timothy says 7 to the power of 7 for the first one. Good job. Okay, and 7 factorial for the second one. Okay, nice, excellent. Okay, those are obviously going to be really, really big numbers, which we can work out what they are. But I mean, if we leave it like that, that's also fine. That's not a problem either. Okay, Cheeto, 8, 2, is that for 7? Yeah, same as Timothy. Okay, so 7 to the power of 7. Yes, indeed. That's 8, 2, 3. Atankosi, you're saying B is that. 5, 4, 8. Atankosi says 7. Factorial is, indeed it is. Indeed it is. Well done, guys. Lovely. Nice. Okay, so can everybody see the difference between exponential notation and when we're going to use exponential notation? Oh, Christian, is it possible to type 7 factorial into the calculator? It most certainly is. Now, I don't know which calculator you've got, but I've got a Casio, and my factorial button is located close to the very top on the right-hand side. You would have to use the shift button to activate it. So on mine, hang on a second, I've got my glasses on today, so I'm battling to see a little bit. You will see, Christian, something like that, but you probably have to activate the shift key. So I know on my calculator, I have to press 7, shift, and then the button has got x to the power of -1, and then the shift is the factorial. Okay, have you found it? You see it, cool. All right, so yeah, you can use that, at least saves you a little bit of time. Okay, all right. Okay, let's move on. So we've done simple combinations, we've done word arrangements where letters can be repeated and can't be repeated. We've begun to speak about factorial notation. So let's just explore this whole idea a little bit further. All right, so what we've done now, or what we've done so far, is we've said we wanted to fill 8 boxes with 8 letters, 8 factorial. Or we wanted to fill, in the case of the example that we've just done over here, the word Florida, we wanted to fill 7 boxes with 7 letters without repetition. That was 7 factorial. All right. So again, how many ways can we seat 6 people in the first 6 seats of a movie theater? It would be in 6 factorial ways. But we don't always necessarily want to fill every single seat. So what do we do, Matrix, when this happens? Okay, now let's say we've got 7 vacant places. Okay, we've got 7 boxes to fill, but we have 10 people. How would we do that? How would we fill 7 boxes with 10 people? Anyone got an idea that they want to share with me? Okay. Cheeto, thank you for your answer, but unfortunately that can't be right. Okay, Cheeto, when you say 10 to the power of 7, you are using exponential notation, which means that repetition can occur. So there can't be repetition of people. Okay. Sake says, is it 10 factorial divided by 7 factorial? It's 10 factorial divided by something, but it's not 7 factorial. Sake, you're very, very close. Okay, so let's talk about this. Okay, so because either we can write it out in full, or we can use factorial notation, which is going to be a little bit quicker for us. Okay, you said, oh, 6 factorial. It's not 6 factorial either, but don't stress. I'm going to show you now what it is. Asipe says 60488. I actually haven't worked out the number. I have to put it on my calculator. By 4 factorial, it's actually 3 factorials, okay? Yes, 10 factorial divided by 3 factorial is correct. That's it. Yeah. Okay. All right. Okay, so let me just explain to you why. Okay, this is really cool. So let's just create some more space here. Okie dokes. So we are trying to fill 7 boxes. Okay, so in the first box, we can fill that. The first box can be filled in 10 ways. The second box can be filled in 9 ways. The third box can be filled in 8 ways. The fourth box can be filled in 7 ways. The 1, 2, 3, 4, the fifth box can be filled in 6 ways. 1, 2, 3, 4, 5. That one. And then there's the 7th box. That's how many ways we could fill the boxes. All right. But now if we didn't want to write all of that out in full, all right, what we've really got here, guys, is 10 factorial. Just bear with me. So 10 by 9 by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1. I mean, who wants to do this every time? But we stopped at 4. So that means that we need to divide by 3 by 2 by 1. Okay, and that's where we get 10 factorial divided by 3 factorial. Okay, you see where it comes from. So that just makes it a little bit quicker for us to be able to work it out. All right, instead of having to write 10 times 9, times whatever the case is. All right, so 10 factorial divided by 3 factorial, which is... Thanks, Benedict. Cool. Okay, everybody getting the same answer as Benedict. 604800. I have no doubt that that's right. 3 factorial, Benedict. Indeed. Okay, good stuff. All right. Does that make sense? Okay, so there's a couple of people that didn't. Okay, so some people are saying, yes, that's great. All right, let's see what we can do here. So now for the people that it makes sense to, I want you to do something on your own. The people that are struggling, then you can listen to me, okay? So the people that have said yes, so Sake, Timothy, Nala, Olusola, Atinkosi, Slindile. Please will you try what's in the middle of the screen now? Okay, so this is number 1, A and B. Okay, I want you guys to think about that. The people that were struggling, so I'm just going to move that down a little bit. Okay, so everybody, that's fine. You're doing this question over here that I'm busy shaking around now. Those of you that didn't understand, okay, just listen to me explain this again. Okay, it's no problem at all. It's difficult in the beginning, so I completely appreciate it. All right, so what we're going to do. All right, so now I'm speaking specifically to Malatana, Melakule, and cool, Christian, that's good, well done. And to who else? Deneo. Okay, so what's different now, Melakule and Deneo, is the fact that we are not filling 10 boxes in 10 ways. We're filling seven boxes, but with 10 different people. Okay, so that means that not every single place is going to, well, I mean, every single place is going to be filled, but not every single person is going to be used. All right, so once we have filled the boxes, all right, there's going to be 3 people that have not been able to take a seat. All right, so we have seven boxes. Here's our 7 boxes. There's the first place, the first vacant place, the second vacant place, the third vacant place, the 4th vacant place, the 5th vacant place, the 6th vacant place, the 7th vacant place. Okay, so there are 10 people standing around. So there are 10 people that could potentially use that spot. Once somebody sits down, there are only 9 people left. Once 2 people have sat down, now there are 8 people left. So now to take the 3rd chair, there's a choice of 8 people. Now 3 people are seated. Okay, how many people are still standing? 7. So there are 7 possible people that could choose that chair or could go into that chair. Does that make sense to you? By 6 by 5 by 4. All right, but that is not 10 factorial. This is not the same as 10 factorial, because 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So if we want to write this, you don't have to write it in factorial notation. If you want to write what I've just got here, 10 by 9 by 8 by 7 by 6 by 5 by 4, you can do that. But if you want to write it with factorial notation, you are going to have to account for the fact that there's no times 3 times 2 times 1 at the bottom, which is why we would have to divide by 3 factorial. Okay, in order to get our answer. I hope that makes a little bit more sense. There's a whole lot of messages down at the bottom here. Okay, so 1A, Atin Corsi says 40320, which is 8 factorial. I agree with you. Cheeto, you're quite right. Your answer for A is correct. Melakuset would be exactly the same thing. Timothy, yeah, 15 factorial divided by 10 factorial. 15. Yes, yes, yes. Okay, all right. So those of you that tried these questions, good. Well done. You seem to understand. You seem to understand what's going on. Thank you so much for all your responses. It's so cool. I'm really pleased. Okay, so all of you told me. Where am I? Pen. Okay, let's have a different color. So you all said for the first one that was 8 factorial. Okay, which ended up being, what was it now? 40320. Good. All right. And then the last one, you guys got 36360, which is correct. So in how many different ways? in how many different ways can 5 vacant places be filled by 15 different people? So 100%, guys, that would be 15 factorial divided by 10 factorial, or if you want to do it the long way, okay, it would have obviously been 15 by 14 by 13 by 12 by 11. 1, 2, 3, 4, 5. Okay, but it's just easier to say 15 factorial over 10 factorial, and you're all right. 360, 360. Okay, so how are we feeling now compared to when we started? Are we feeling a little bit more confident? Thumbs up, thumbs down. Okay, good stuff. All right. Okay, so now I picked this question on purpose, okay? And I want us to do it together and for you to, again, just interact with me as much as you possibly can, okay? So let's read the question. It tells us the digits 0, 1, 2, 3, 4, 5, 6, 7, and 8 are used to make 4-digit codes, okay? So how many digits do we have? Pop it into the chat. How many digits have we got, guys? Okay, so all of you who said 9 are correct. Absolutely. Okay, so we would have 8 digits if we started counting at 1, but we started counting at 0, haven't we? So that means that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 possible digits. Now that's really important. Okay, we've got to count the number of possible digits that we've got, right? So everybody that said 9, well done, that's right. So we've got 9 possible digits, and we want to make 4-digit codes. Can you see how it's related to the question before, right? Because you've got 9 possible ways to fill something, but we're not filling 9 places. We're only going to fill 4 places, right? Let's look at what the questions say. All right, so in question A, Matrix, how many different codes are possible if the digits may be repeated? Okay. So a CP says 6561. All right. Where do you get 6561 from, a CP? What is 6561? Where did you get 6561 from, a CP? What did you say? You're right. There we go. Okay, Nala, quite right. Okay, Silindile, it's not 9 to the power of 9. Okay, unfortunately not. I know Sam Timothy also said that. Okay, it's not 9 to the power of 9 because we're not making a 9-digit code. We're making a 4-digit code. All right. So again, draw your boxes. I really do think that helps. Okay, so there's the first digit. Yes, yes, Christian. Yes, Asipi, that's it. There we go. Okay, we've got 4 boxes that we're allowed to fill. Okay, we are allowed to repeat numbers. Okay, so we've got 9 digits we can use. So I've got 9 options for the first digit. Because I'm allowed to repeat, I've got 9 options for the second, 9 options for the third, 9 options for the fourth, which gives me, I'm squeezing it in here, 9 to the power of 4, which is the 6561. Okay, cool, good stuff. Next question. How many different codes are possible if the digits may not be repeated? Okay, so again, it relates back to something that we've already spoken about. Anybody want to pop something into the chat? Okay, so Benedict, hold on a second. Benedict said 3024. Cheeto says 1680. All right, guys. All right, you're going to have to tell me. And then Christian says, same as Benedict. Okay, CP 9 factorial divided by 5 factorial. 3024. All right, lovely. Okay. You started at 8. Okay, all right, perfect. Okay, so guys, 9 factorial divided by 5 factorial. Okay, so 3024 was indeed the correct answer. Okay, well done. So that relates back to what we were talking about. Now things start to get a little bit more interesting. Look at question C, Matrix. How many codes are numbers that are greater than or equal to 4,000 and are exactly divisible by 2? Digits may be repeated. Karabo, you saying why 5 factorial? Okay, so everybody else, I want you to just think about question C for a moment. Karabo, I'm going to explain that to you, okay? Here on the side. So everybody else, you think about question C for 2 seconds. All right, Karabo. All right, how many boxes are we filling, Karabo? We are filling 4 boxes, right? But we are not allowed to repeat letters. So that means that we can fill the boxes 9 by 8 by 7 by 6, which is the same as 9 by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1, which is 9 factorial, over 5 factorial. So in other words, over 5 times 4 times 3 times 2 times 1. So what it does is it stops us having to write out this whole long thing here, Karabo. I mean, who wants to write more in maths when we don't need to? I mean, we're always trying to save time. Okay, so it's 9 factorial divided by 5 factorial. And then what happens here is that ends up cancelling with that, and we just get what we wanted. Okay, or if you want to write, Karab, if you want to write 9 by 8 by 7 by 6, the same thing. Okay, no problem at all. It's up to you. It's just if you do want to use factorial notation, that's how you would do it. Cool, no problem. All right, so now I'm super interested to hear what you guys think about question C. All right, so again, we are filling 4 boxes, right? Because the code has to be a 4-digit code. Right, so now, in how many ways can we fill the first box? So in other words, this box over here, this one. What do you think? How many ways can we fill that box? Okay, remember, same story. We've got 9 possible numbers, but the number has to be greater than 4,000. So Olusola says that we've got 4 options for the first box. Why 4? So, oh, that's your final answer. So CP says 720. Hold on a CP. Okay, that's not my final answer. Okay. Cheeto, there we go. Okay, so just listen to this carefully. Okay, CP. Cheeto, you're correct. We have got 5 options exactly to fill the first box. All right, 5 ways we can fill the first box, because it can be count on your fingers, guys. It can be a 4, a 5, a 6, a 7, or an 8. Does that make sense to everybody? So there are 5 options to fill the first box. All right. If the digits are allowed to be repeated, then in how many ways can I fill the second box? I'm allowed to repeat my digits. So how many options do I have for the second box? Pop what you think into the chat. Unfortunately, not Christian or Cheeto. Remember, I'm allowed to repeat. So it doesn't matter if I've used 4 or 5 or 6 or 7 or 8. I can go back and I can use those numbers again. Not 10, Swelihle, it would be? It would be 9, indeed. It would be 9. Okay, remember, we've got 9 digits that we're working with in the beginning. Okay, does not matter that we used one of them in the first box. We're allowed to repeat, so we've still got a choice of 9 to fill the second box. All right, how many do we have to fill the third box? We've still got 9 because we're allowed to repeat. Okay, but now, guys, we've got to be so super careful here because these numbers have to be exactly divisible by 2. So when numbers are divisible by 2, what do they need to end in? They need to end in 0 or 2 or 4 or 6 or 8, because only even numbers are divisible by 2, right? Exactly, even numbers. So now go back and have a look. Out of the 9 original numbers that we were working with, how many of them are even? How many even? Indeed, 5. There we go. Good, well done, very nice. Nala, I'll explain it to you again, not a problem. Okay, so this ended up being 2025. Nala, the reason that we started with 5 is because in this first box over here, right, this is where the thousands would go, the thousands digit, because remember we're trying to make a number that is greater than or equal to 4,000. Okay, so in this block over here, the one where I'm drawing the arrow, we have got, because I can't make a number, I can't make 3,000 and something, I can't make 2,000 and something, I can't make 1,000 and something. It's got to be a number that's 4,000 or bigger. So that means that the number has to start with a 4, a 5, a 6, a 7, or an 8. There are 5 options. Okay, so if it has to be 4,000 or bigger, Nala, it has to start with a 4 or a 5 or a 6 or a 7 or an 8. There are 5 different ways we can fill that first box. Okay, makes sense. Cool beans. Oh, good. I'm glad. All right, now, all right, for the last question. All right. How many codes are numbers that are, let me start that again. How many codes are numbers that are greater than 4,000 and are exactly divisible by 2? This is a trick question. It's so easy, it's difficult. Well, I don't think that's easy to see. All right. And it relates back to what we've just done. Remember, we've just worked out how many numbers there are. Remember this 2025 over here. What does it represent? It's the number of codes that are greater than or equal to 4,000 that are divisible by 2. So now if we want to work out how many codes there are that are just greater than 4,000, what do you think we need to do? Anyone got an idea? Even if it's wrong, guys, like, there we go. Exactly. Remove one possibility. Brilliant. Brilliant, brilliant, brilliant. Yes, exactly. Yes, the answer would be 2024. There you go. Remove one possibility. Good stuff. Well done. Give yourselves a hand of applause. Here, I'm going to give you one. Hang on, let's just find the clapping hands here. It is a tricky question. And isn't it interesting, Christian, because it's one of those questions that it's so simple that it's difficult. It's so easy, it's difficult. Okay, but well done, guys. That was really good. How are you feeling? Thumbs ups, thumbs downs, making sense? I think this is such an interesting part of maths. I love this section myself, so are we all feeling good?
Ma'am, would you please explain D for me again?
Sure. All right. So no problem, Atin Corsi. I can see Cheeto also says that he doesn't understand how to do that question. All right. So guys, just give us a couple of seconds. Then we're going to talk about the arrangement of objects in a row. And we can carry on going. Okay, so you want me, so is it just D that you want me to explain, Cheeto? Question D is related to question C. All right, in question C, cool. In question C, we worked out that including the number 4,000. So if there was a code that was the number 4,000 or anything bigger than 4,000 and divisible by 2, that would give us 2,025 different possible options. What they're asking us to do in question D is they're asking us to exclude one of those options by telling us that the numbers just have to be greater than 4,000. So in other words, we are excluding the number 4,000. That is one of the options. Okay, so out of the 2,025 numbers that we possibly had, they've said to us, we'll exclude the number 4,000. So we are excluding one option. And that's why it's 2024. Does that make sense? All right, so you can only answer question D by understanding question C. So we've just removed one option. Okay, question C said for 4,000 or bigger. In question D, it says just bigger than 4,000. So we're removing the option 4,000. It's one option, and that's why it's gone from 2025 options to 2024. Okay. All right, well, I hope this is making sense to all of you. Let's move on and talk about the next thing. So this is the arrangement of objects in a row. And they love these sorts of questions in exam type questions. So that's why this is something that we need to talk about, right? So sometimes it's books, sometimes it's things hanging on a rail, sometimes it's people that want to sit next to one another, etc., etc. All right, so the example that I've chosen to use this evening with you guys is this one. So let's just pop that out the way, 4 history books and 3 geography books must be placed on a shelf. In how many different ways can you arrange the books on the shelf? All right. How many books are there? Exactly. So is this a case of exponential notation or is this factorial notation? Exactly. We've got 7 books. So how many ways can we arrange them? Is it 7 to the power of 7? Or is it 7 factorial?
Isn't it 7 to the power of 7, ma'am? Because it's like 7 books, so you can put them in 7 different ways. Because it's only 7 of the books.
Fair enough, Atinkosi, but the thing is that the books are not like numbers or like letters. Once you've already placed a specific book on the shelf, it can't be repeated. Okay, so in this case, the books function like people do. Okay, there can't be repetition because we've already used that book. Does that make sense to you? Okay, so it should be factorial. All right, and those of you that said factorial, good job. Okay, so let's just get the pen going. All right, so in question A, there are 7 factorial ways in which these books can be arranged on the shelf, 100%. And of course, we all know that 7 factorial leaves us with, we've done this before, 5040, indeed, good job. Thanks, Christian. All right, question B. Now it says to us, if all the history books must be placed next to each other and all the geography books must be placed next to each other, in how many ways can we arrange the books on the shelf? So now there's yet another restriction. So this is what we do, all right? I do this by drawing little bubbles. The history books need to go together. So history book, history book, history book, history book. They've got to be together. And the geography books need to be together. Geography, geography, geography. Okay. In how many different ways can the history books be arranged with one another? In how many different ways can the history books be arranged with one another? Exactly, 4 factorial. Good, Swelly. Yes. Okay. In how many ways can the geography books be arranged with one another? You can pop it into the chat. 3 factorial. Good. Now, the only thing that we still need to consider, in how many ways can the whole group of history books be arranged with the group of geography books? Exactly, 2 factorial. There you go, you got it. Okay, so it's going to be 4 factorial by 3 factorial by 2 factorial. Okay, does that make sense, everybody? 4 factorial by 3 factorial by 2 factorial. All right, so how many ways is it? 288. Excellent, there we go. All right, are we happy with that? Question C, let's have a look at this now. If just, okay, good, Timothy. Everybody else happy? Timothy's given us a thumbs up. The rest of you, is this making sense? If not, I can always do another example. It's not a problem. Sure, okay, cool, thanks. Okay, just stop me if you don't understand, hey? Seriously, there's no stress at all. All right, so now let's look at the next thing. Okay, so if just the history books are to be together, in how many ways can you arrange them on the shelf? So just the history books together, Matrix. Again, the way I like to do this is I like to draw bubbles for myself. All right. So yes, it would, part of the answer is going to be 4 factorial, absolutely, because Karabo, you've got history book, history book, history book, history book that all want to be together. But then the geography books are basically on their own now. So let's just move down. Sparkle says 4 factorial. I agree. 4 factorial is part of the answer, right? There are 4 factorial ways that the history books can be arranged with the geography books. So 1, 2, 3, 4 factorial ways. But there are also within the bubble with H, there are 4 factorial ways that the history books can be arranged with one another. So that's going to be 4 factorial by 4 factorial. Does that make sense, Matrix? Yes, indeed, Christiane, 576. Okay, so 4 factorial by 4 factorial is 576. Good. All right, everybody happy with that? Lekker. Okay, so now, okay, Atom Corsi. Okay, so Melakukle, that's fine. Okay, Sabahle, that's fine. I'll explain that to you. What I'm going to do again is people that understand, you carry on with your turn. You have a look at number 5, all right? Try and answer, or not try and answer questions 5A and B. Ignore me for now. I'm just going to speak to Skytle and Melakufle, who said that they didn't understand 4 factorial by 4 factorial. Okay, so here we go. The others, don't listen to me. You're doing your own work here on number 5, okay? And then we'll talk about what answers you got when we're back and we're finished. Okay. When we arrange objects in a row, Sabahle, I think the easiest way for us to do this is to use bubbles and to group things together. Okay, so this particular question says to us that, sorry, let me just move it down a little bit. The history books had to be together. Okay, so the history books had to be together in a bubble. So that means we've got to have a history book next to another history book, next to another history book, next to another history book. That has to happen. Okay, So now, if we have got the 4 history books next to one another, do you agree with me, Sabathi? There are 4 factorial ways that we can arrange them together. Okay, because there's 4 of them. So 4 by 3 by 2 by 1. So within the bubble, there are 4 factorial ways in which we can arrange the history books with one another. But the history books as a whole, because they've got to stay together, can still be arranged with 3 other items. So that is one geography book, another geography book, and another geography book. Right. So they as a group can be arranged with the geography books in 1, 2, 3, 4 factorial ways as well. So that's why it's 4 factorial by 4 factorial. Okay, so 4 factorial is within the bubble, how the history books are arranged with one another. And the second 4 factorial is how the history books as a group are arranged with the geography books. Does that make sense, Sabahle? Okay, all right. And again, please, if it doesn't, ask me. I really, really don't mind. Okay, so that was 576. Okay, pleasure. All right, so let's move this up. All right, so now your turn. In how many ways can 4 maths books, 3 history books, 3 science books, and 2 biology books be arranged on a shelf? Has anybody been able to answer 5A? Cool, Christian, you say 12 factorial. What do the rest of you reckon? Okay. Lekker, nice, good jobs. Okay. I quite agree. All right, so we counted how many books there were. 4 plus 3 plus 3 plus 2, that gave us 12 books. So yes, they can be arranged in 12 factorial ways. All right, so 12 factorial is going to leave us with, would we even write that out? Yes, Cheeto. What is that number? How do we even say that? 40, no, 479 million. 479 million. I don't even know how to say that. That is 479 million. And I don't know how to, and 600. I don't know how to say the one. Okay, anyway, it doesn't matter. All right. That is a lot of different ways that we could organize books on a shelf, isn't it? Crazy. All right, part B. Now they said be arranged so that all the books of the same subject are arranged together. Okay, so all right, hang on a second. So we've got 41472 as an answer, 4 factorial by 3 factorial by 3 factorial by 2 factorial. Christian says 4 by 3 factorial. Okay. Cool, well done, guys. All right, so let me rub that out. Okay. So, why 4 factorial? Why is the first one 4 factorial? Where does the 4 factorial come from? What are you talking about there exactly? So the 4 factorial is the number of ways in which the maths books can be arranged with one another, right? Then by 3 factorial is how the history books can be arranged with one another. By 3 factorial is how the science books can be arranged with one another. By 2 factorial, how the biology books can be arranged with one another. But did we consider that each of those 4 bubbles have got to be rearranged with one another as well? So it's got to be by another 4 factorial. Okay, so 4 factorial. Let's work this out for. Yeah, you see, Swelith, you mustn't forget, once you've rearranged them with one another, how they then got to be arranged in the groups with each other, with the different bubbles. Okay, so it's 4 by 3 factorial. So I'm sure one of you can work the answer out faster than me. By 3 factorial, by 2 factorial, by 4 factorial. There we go. That's it. Yes, okay, quite right. Okay, good job. Okay, 4, 1, 4, 7, 2. Matrix, does that make sense? Do you want me to explain it again? You can pop something into the chat. If you want me to explain it again, say yes. If you don't want me to explain it again, you can say no. You're fine. Cool, Christian. Thank you. Okay, so it makes sense to everybody. Okay, CP said yes. Okay, so CP, let's see. Makes sense. Okay, so CP, what I want to do, I think we'll have enough time. I want to get onto questions involving probability. Right, but a CP, just very, very quickly, this is what I've done. All right, so I'm just going to fly through this again so that we can move on. All right, we've got 4 maths books. Okay, so that's 1, 2, 3, 4 maths books. They all want to be together. Okay, 3 history books. History, history, history. They want to be together. Science books. How many? 3. They want to be together. Biology books, they want to be together. Okay, so this is where, so this 4 factorial here is that 4 factorial over there. This 3 factorial here is this 3 factorial here. That 3 factorial there is for this. And this 2 factorial over here is for this. But in the ways in which the 4 bubbles can be arranged with one another, there are also 4 factorial ways in which the bubbles can be arranged with one another. So that's why it's by an additional, by an additional 4 factorial. Okay, so this last one over here describes the number of ways in which the bubbles can be arranged with one another. The first 4 numbers, or first 4 factorial factors. Does the second 4 factorial include all the books? Yes, so it explains how the maths books can be arranged together with the history books, with the science books, with the biology books. Okay, so there are now 4 groups that want to sit together, so that's 4 factorial ways in which they can be arranged with one another. Okay, so we look at it in sort of internally, how they can be arranged next to one another within their group, and then how the groups can actually be arranged with one another. Okay, all right, so moving on. Questions involving probability. Okay, so we're definitely going to get something like this in our final exam. Okay, I'm glad, CP. I'm glad you feel you understand now. Okay. All right, let's talk about probability, because up till now, we haven't spoken about the likelihood or the chance or anything like that. We've just spoken about the different number of possible combinations, or the number of ways in which something can happen or be arranged, or et cetera, et cetera. So now we've got to consider likelihood or probability. So let's look at this. Consider the letters of the word dreams. If the letters are arranged in any order without repetition to form different words, what is the probability that the word will start with a D and end with an S? So now there's a little bit more going on here than before. First of all, okay, not only do we have to be concerned with the fact that it says probability, but they're also giving us some restrictions. Let's just first talk about probability. Okay, so how do we calculate probability, first of all? probability is calculated. So the probability of any event happening is going to be the number of ways that that event can happen divided by the total number of possibilities that are allowed. Okay, so what we're going to have to do is we're going to have to do this by using a numerator and a denominator. That's how we're going to write a probability. Okay, so it's the number of ways in which what we are looking for divided by the total possible number of ways. So let's start with the denominator. Okay, so here we want to answer probability, start with D and end with S. Let's just get rid of that. Okay, so there's the divide line. Okay, our denominator has to be the total number of ways in which the letters D, R, E, A, M, S can be arranged. Okay, so now this is kind of pulling together everything that we've spoken about from the beginning of the lesson till now. All right, and so any order without repetition. What do you guys think? What is the denominator going to be? How are we going to work out what the denominator is? Good, 6 factorial. Okay, so the number of ways that the 6 letters can be arranged is going to be 6 factorial. Good job. All right, so that's going to be my denominator. Right. Now let's think about the numerator. All right. How many boxes am I filling? I'm filling 6 boxes. Let me draw them for you. Okay. Box 1, 2, 3, 4, 5, 6. Okay. Now it's said to us that the words, the letters had to be arranged without repetition. So without repetition means we need to start thinking about factorial notation, not exponential facts. Okay, FCP, you're on the right track, 100% to form different words. Okay, so yes, FCP, we can only fill the first block in one way, FCP, because it has to be a D. We can fill the last block in only one way because it has to be an S. But they told us that we were not allowed to repeat. So how many letters have we used? We've used 2 letters, the one that went in here and the other that went in there. So that means we have 4 letters left. So we have 4 letters that could possibly go into the second position, 3 that could go into the third, 2 that could go into the fourth, and only 1 letter left. Okay, all right, so FCP, you were correct. You just left out the factorial. Okay, so this is going to be matrix. It's going to be 1 by 4 factorial by 1 over 6 factorial. Okay, which is going to leave us with 1 over 30. Okay, so now everyone's quiet. Are you quiet because this makes sense, or are you quiet because you're horrified? How are you feeling? You can pop something into the chat for me. Bit of both. Okay, it makes sense. Okay. Really makes sense, Cheeto. Okay, thanks, Neo. Thanks, FCP. It's getting there. All right. So really what we're doing is we're putting together two things that we actually already know. We've worked with probability before. All right. So we've worked with things like, for example, if we have got 3 bar ones and 2 Kit Kats in a box, what is the probability that we are going to put in our hand and take out a Kit Kat? It would be 2 out of 6, because there are 2 Kit Kats. There's 2 ways it can happen. That's the numerator. Out of the bottom, because there are 6 chocolates. It's exactly the same idea, except we're now working with our factorial notation and the number of ways in which things can happen. Okay, so we're sort of blending together these two concepts. I think I do have another example. Okay, this is quite a tough one, but let's try this. Okay, the reason I chose this question as well is because there's something in question C that I wanted to show you. All right, so let's have a look at this. A combination to a lock is formed using 3 letters of the alphabet, excluding the letters O, Q, S, U, V, and W, and using any 3 digits. The numbers and letters can be repeated. Calculate, excuse me, I beg your pardon, calculate the probability that a combination chosen at random. Okay, but before we even think about starting to answer the questions, the first thing that we need to consider, all right, how many boxes are we trying to fill in our numerator? How many boxes are we trying to fill in the numerator? Okay, so it's 3 letters of the alphabet and any 3 digits. Exactly, Swelihle. We've got 6 places we're going to fill. So we have got letter, 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 by digit, by digit, by digit at the top. Does that make sense to everybody? Okay, so the first three are letters. The second 3 are digits. All right. Let's consider what has to happen in the denominator. All right. So again, we are filling 6 boxes. Let's just get a different color. Green. Okay, because it's letter, letter. Ah, yes, Timothy, there we go. I see, yes. Now you're starting to think. Good, well done. All right, so okay, so it's up to you. We can either do the numerator first or the denominator. I always prefer to do the denominator first, but that's just me. So yeah, let's work out what needs to go at the bottom. So the others, I don't know if you've seen in the chat, Timothy said, so does that mean we're only using 20 letters? Asipe says letters will be formed from 20 options. Quite right, because there are 26 letters in the alphabet, isn't it? But we are removing 1, 2, 3, 4, 5, 6 of them. Correct. So that means that the number of options has been reduced from 26 to 20. Okay, so that means, all right, that we have 20 ways in which we can choose the first letter. All right, we're allowed to repeat. Okay, so there will be 20 ways in which we can fill the second box, 20 ways in which we can fill the third box. Now, as far as our digits are concerned, our digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many digits do we have, Matrix? Yeah, exactly. We've got 10 digits. Quite right. Okay, by 10, by 10, by 10. Good job. Okay, so exactly. So essentially 20 cubed by 10 cubed is what our denominator is going to be. That is the total possible number of combinations that can be made from 20 letters in filling 3 boxes and 10 digits filling another 3 boxes. Okay, so that's cool. Let's concentrate at the top. Now it tells us it has to start with an X and it has to end with a 6. Okay. But the numbers and the letters can be repeated. Numbers and letters can be repeated. That is so important for us. I'm just going to highlight that again. Numbers and letters can be repeated. The numbers and the letters can be repeated. Okay. All right. So filling the first box. So now we're talking about question A. Okay, guys? It has to start with the letter X. So in how many ways can I fill box number 1? It has to start with an X. Exactly. I can only with 1. Exactly. Perfect. Hundreds. Well done, guys. Mara, Nala, all of you. Perfect. I have got 1 way in which I can fill the first box. Okay. It has to be an X, right? They told me I am allowed to repeat. So in how many ways can I fill the second box of letters? I'm allowed to repeat. What do you think should go into the second box? How many options do I have for the second box if I'm allowed to? I'm allowed to repeat. Yes, Timothy. Swelile, if I wasn't allowed to repeat, it would be 19. But because I'm allowed to repeat, I've got 20 options here. Good matrix. Excellent. And as far as my third letter is concerned, I'm allowed to repeat. Yeah, I've still got 20. Right, Atin Corsi. Perfect. Good job. All right. Now let's talk about the digits. Okay. It has to end with the number 6. So this end box over here, it can only be filled in 1 way. It can only be the number 6. So I've only got 1 way in which that box can be filled. But remember, I'm allowed to repeat. So in how many ways can I fill the first box of digits? What do you reckon? Indeed. Good, Olusolo. Good, Silindile. Excellent. Okay, I've got 10 ways in which I can fill the first box that belongs to the digits. And again, because I'm allowed to repeat, I have got 10 ways in which I can fill that box. Okay, so that's how we're going to work out the probability that this combination starts with an X and ends with a 6. All right, so let's pop that massive, huge, big thing into our calculator, guys, and work out what the answer is. So once you've done that, you can pop that into the chat as well. What are you getting? Anybody got an answer yet? No. Right, so the number at the bottom, 20 by 20 by 20 by 10 by 10 by 10, is 8. Yes, 1 over 200 is the final answer, CP, 100%. Okay, so it ends up being 40,000. Yes, indeed. Well done, Benedict. That's quite right. It ends up being 40,000 over 8 million. 1, 2, 3, 1, 2, 3, which, as you were all telling me, yes, Rechumeditswe, good job, is 1 over 200. Okay, nice, well done. Right. So now let's do something a little bit, it's a slow process of us building stuff up. Okay, let's consider question B now. We want to calculate the probability that a combination chosen at random has exactly 1x. Right, so it's only allowed to have 1x. Okay, so first of all, is the denominator affected in any way in this particular question? Is the denominator from A going to B? Is it going to be any different? No. Okay, so we already know what that is. All right. So what I'm going to do, if that's all right with you, I think you guys have got this written down. I'm just going to rub it off so that there's a little bit of more space for me to write here instead of jumping up and going down again. So I'm just going to rub that off quickly. Okay. All right, so we all agree that as far as question B is concerned, exactly 1x. Okay, so we all agree that our denominator is not going to change. It's still going to be that massive 8 million. But what's going to happen in the numerator? Okay, so let's have a look at this. Remember, we've got six boxes we're trying to fill. 1, 2, 3, 4, 5, 6. Right? So if it has exactly 1x, right? Remember, the first 3 are the letters, the second 3 are the digits. Right? So if I fill the first box with an x, there is only one way I can fill the first box. How many ways can I fill the second box of letters? Remember, I'm only allowed 1x. So am I allowed to repeat? Ah, yes, 19 ways. Good. Yes. Good job. Okay. And how many ways am I going to fill the third box? Still 19, exactly. I've still got 19 ways because it's only the x that I'm excluding. Okay, so I've still got 19 ways. As far as the numbers are concerned, do I need to worry about excluding any digits? No. Okay, so this is going to be 10 by 10 by 10. All right, what are we not considering, Matrix? When we look at this, we're only considering that the x is in the first box. But the x doesn't necessarily just need to be in the first box. There are 2 other boxes that the x could be in, isn't it? The x could also be in the second box over here. And the x on its own, it could also be in that box over there. So now we need to consider additional ways of our combination. So now we have to use addition. All right. So 6 boxes again. All right. Remember, we're allowed 1x. So now, if the x was in the first box the first time round, let's say that the x is in the second box the next time around. Does it make sense then that there would be 19 possible letters that we could use in the first box and 19 possible letters that we could use in the third box? Does that make sense, Matrix? Thumbs up, thumbs down? Yes? Cool beans. Well done. But we're still not finished because now we've considered the x in the first box. We've considered the x in the second box. We've also got to consider that the x could be sitting in the third box. So now we have to add again. All right. So now we're adding again. 1, 2, 3. Ooh, oh my word. Hang on. Why does it have to do that? So annoying. Sorry, Matrix. Hang on a second. Sometimes I end up clicking something funny here on my pen and it goes crazy. Where were we? Okay, we were drawing 6 boxes, weren't we? So 4th box, 5th box, 6th box. Okay, so we agreed. We've considered x in the first box. We've considered x in the second box. We now need to consider x in the third box. So what should I write now? Anybody want to tell me what should go in the first box? What do you think, Matrix? What should go in the first box? 19. Hundreds. Excellent. What should go? Yes, that's in Corsi. Yes, Silendile. Yes, Christian. Yes. Cool, guys. Well done. Okay, now, what goes in the second box? Sakis is also 19. Okay, oh, there we go, Nala, thank you. That's it. Well done, FCP. Well done, Nala. That's right. Okay, so 1 by 10 by 10 by 10. And then all of this, guys, let me just make sure that I don't do any weird things, has to go over that crazy big number, 8 million. Okay, so another way that we could write this, if we wanted to, let me just sort of make this. Yes, we could do that too, Christian. Quite right. Did you see what did everybody see what Christian put in the chat? It says, wouldn't it just be easier to multiply the first line by 3? Indeed it would. Okay. All right. So the other way that you could set this out, well, mind you, I suppose there's no point in us doing that. You understand what I'm saying. Work it out. Work out what we get here. And then pop it into the chat. Tell me what you get. What do you get in the numerator matrix? I didn't get that at Nkosi. Yes, Silindile, that's what I got as well. Okay, at Nkosi, what you doing? Yes, that's right. That's it, a C pair. Yeah, at Nkosi, that's correct. Yes. All right. So it's going to be 1083 zeros like that over 8 million. 8, 1, 2, 3, 1, 2, 3. All right. And exactly. So when we simplify it, we're going to end up with 1083 out of 8,000. Okay, so I chose this example on purpose, Matrix, because I wanted you to see what would happen in a situation like this where we've got 1x, but then we would have to consider that it could go into the first box or into the second box or into the third box. Okay. Yeah, Silindile, it's 1083 over 8,000. Okay, maybe you just forgot, you just made a little typo. Okay, because we're going to knock 3 zeros off the end here, and then we're going to knock 3 zeros off the end there as well. Okay. All right. So now after that massive big question, let's consider the last one. All right. And again, I chose this question on purpose because there was something here that I wanted to illustrate to you. Okay. I'm going to rub this off now because again, we need this space to write. So I'm just going to get rid of everything. And I'm going to start this last question with a different question. Okay, so let's just consider this. All right, let's pretend I've got a bag. All right, so there's a bag, and in the bag are 4 red blocks, 3 blue blocks, and 5 green blocks. What is the total number of blocks in the bag? You can pop it into the chat. The total number of blocks in the bag. Cool, there's 12. So you got that by saying 5 plus 3 plus 4. All right. So now if I say to you, Matrix, what is the probability of you choosing a red block? What would you say? What's the probability of, at random, of you choosing a red block? Exactly. Exactly, Sake. Quite right, Rehumadetswe. Absolutely. You have got a 4 in 12 chance of choosing a red block. Now, I'm going to ask you, what is the probability of you not choosing a red block? What is, so now, same story, same scenario, but now I'm saying to you, what is the probability that you are not going to choose a red block? 8/12. Okay. How did you get the 8/12? What did you do? So, there we go. That's exactly it. That's great. Okay, you've got it. All right. So that's what I wanted you to do. So Olusola, you said 12 minus 4, 100%. The others said 3 plus 5. Can you see how you're all right? Okay, 3 plus 5 is 8 and 12 minus 4 is 8. So this sort of question is what we refer to as a complement. Okay, so the red blocks plus the blocks that are not red adds up to the total number of blocks in the bag. Does that make sense to you? Okay, so red plus not red adds up to 1. These are complementary events. Is that something that you've heard before? Complementary events. All right, so in other words, I can calculate the probability of not red by saying 1 minus the probability of red. Or, as the rest of you said, I can add all the not reds together and then put that over 12. Now, I'm using this little example over here to illustrate the concept behind what's going to happen in question C. Okay, I'm going to rub this off now. And now we're going to look. Would we be able to do this in a tree diagram? Yes. Absolutely. Absolutely, you could do it in a tree diagram if you wanted to. No problem with that at all. And then you would be able to work out exactly the same thing. Okay, but here we go. What we're doing, Melekuhle, is that we're applying this concept that I've just shown you with the blocks in the bag to this last question over here, question C. Okay, so if we go back to the same question that we're almost finished now, this combination lock, okay, 3 letters, 3 numbers. All right, now it has to have 1 or more number 6 in it. It has to have 1 or more number 6 in it. So can you see, I don't know if you can, but can you see that this is the same as what what I was talking about now with red blocks plus not red blocks? If it has to have 1 or more 6 in it, it means that there needs to be a 6 in one of the blocks, or 2 of the blocks both have to have 6s, or 3 of the blocks both have to have 6s. Does that make sense to you? So we can do this by either adding together the total number, well, obviously we want the total number of possible combinations. Then we could work out the number of combinations without 6. We could work out the number of combinations with at least 1 6 by subtracting it. And then we can put that over our denominator. That would be the long way of doing it. Or the shorter way would be to use the complement, right? So I suppose I better show you the long way and the short way. So let's get started on this question, all right? But I would prefer to use the shorter method if I was you, okay? All right, so we have got a total number of possible combinations. We agree is 8 million, right? The number of combinations without 6 in them. How would we work out that? Okay, so there would be, remember we're filling 6 boxes, okay? So there are 20 letters. We're allowed to repeat by 20 letters by 20 letters, okay? We're not allowed to have the number 6. So that means that there are 9 ways we can fill this box, 9 ways we can fill the second box with digits, and 9 ways in which we could fill the last one. Okay, so the total possible number of combinations with 6s in it would leave us with 5, 8, 3, 2, 0, 0, 0. Now, let's just move this up. We're going to work out the number of combinations with at least 1 6. So the number of combinations with at least 1 6. So that's going to be the total possible number of combinations. So 20 by 20 by 20 by 10 by 10 by 10 minus the number of combinations without 6 in it. So 20 by 20 by 20 by 9 by 9 by 9. So essentially what I'm doing, guys, is I'm taking my 8 million and I am subtracting my 5,832,000. Right. The answer that I get is the total possible numbers or possible combinations that are going to exist with at least 1 6. So the probability, let's just move this down. So probability of at least 1 6 is going to be 2168000 all over my 8 billion. All right, which leaves me with 217 over 1,000. Okay, that would be one way that I could do this, right? This is the long way. Right? So essentially what I've done here, like FCP said, I've gone 12 minus 4. Does that make sense to you? As an analogy for the other question, that's what I've done here. I've started with a total, and then I've subtracted the number of combinations without 6 in it, and that gives me the number of combinations with at least 1 6 in them. And then I can put that as my numerator over my denominator. Or I can do it the other way, where I can use 1 minus, all right? So your other option here, Matrix, is to do this. Okay, I'm just going to move this down. Let's do this in red. Or your other option here, guys. Okay, so the probability of this happening is going to be 1 minus the probability of it not happening. Okay, so the probability of at least 1 6 is going to be 1 minus the probability of it not happening. So that would be, we already worked it out in the previous question, that would be 20 by 20 by 20 by 9 by 9 by 9. All right, and obviously that needs to go over 8 million. And we get exactly the same answer, but much, much faster. Okay. Oh, hang on a second. Did I do that right? Hang on. I just want to check my 2168 123 over 8 123 123 Oh, sorry, I'm being dyslexic this evening. Sorry, guys. This is, sorry, 271. Beg your pardon. I muddled the 7 and the 1 around. 271. And here would be the same. So 271 out of. Okay, so again, you've kind of gone quiet. Are you horrified, terrified? Or does that make sense? A little horrified. Oh, that's okay. Horrified. Okay. All right. You know what? At the end of the day, it's fine. Okay. Not all of this is going to make sense to us all of the time. This is difficult. This is really, really, really difficult. So if it's not making 100% sense to you, I can completely understand why. All right. I mean, to be honest with you, we could sit here for like 6 hours. I mean, can you imagine how bored you'd be after that? But we could sit here for days, and we could do this. All right. So, but unfortunately, we don't have time for that. What I wanted us to do was just go and have a look at a couple of exam type questions. All right. So we're kind of running out of time. This question here, by the way, the one that's in the middle of the screen, was the question out of last year's paper. All right. So if you go and have a look online at the 2020 paper, that was this question over here. But what I'm thinking, because we've got just a little bit of time left, I think I'm rather going to do that question over there, because this just kind of is a little bit more along the lines of what it was that we were doing. Okay.
The answers.
Pardon?
They can see the answers.
Oh, can they? Oh, whoopsie. Oh. Okay, they weren't looking. Were you, Matrix? No, definitely weren't looking. Okay, so the answers are not sticking out now, are they? Right.
No, it's fine now.
Okay, cool. Okay, so in our last 10 minutes together, Matrix, let's smash question 11. Okay. I know that you can do 11.11 and 11.12 with blindfolded and your hands tied behind your back after everything we've been through this evening. So in the first one, calculate how many unique 5-digit codes can be formed using the digits above if the digits may be repeated. Okay, so what do you reckon? If the digits can be repeated, Matrix? How many boxes are we trying to fill? Okay, so a CP says 7 to the power of 5, 7. Someone else says 5. Okay, so lots of different answers coming through. We are trying to make 7 to the power of 5, says Samara. So we have been given how many numbers? 1, 2, 3, 4, 5, 6, 7 numbers, right? But we're making a 5-digit code. All right, so we are filling 5 boxes with 7 different numbers. Oopsie, hang on a second. Sorry. So yes, 7 to the power of 5. Who said that? Samara. Okay, because the digits may be repeated. Okay, so 7 to the power of 5. Well done. What have I done here? 7 to the power of 5. Suppose we don't need all of those. Okay, whatever that massive number ends up being. Okay, someone said something in the chat. Okay, so yes, 16, that's it. So 16807. Well done, guys. All right, then the next one, 11.1.2. Now the digits may not be repeated. So now repetition is not allowed. What are we going to do now, Matrix? Okay, so Samara, why 7 factorial divided by 2 factorial? Yes, I agree, but why? Why is it 7 factorial divided by 2 factorial? Because we are filling. Exactly, because there are only 5 spaces. Okay, so we've got 7 by 6 by 5 by 4 by 3. 1, 2, 3, 4, 5. Right, exactly, and we can fill 5 spaces. Okay, so if we go 7 factorial by 2 by 1, we have to get rid of that. Okay, so that would have to be 2 by 1 at the bottom. Okay, good job. So 7 factorial divided by 2 factorial. What does that give us, by the way? 7 factorial divided by 2 factorial. Ah, what am I doing? Someone got an answer. 2520. What are the rest of you getting? Yes, 2520 is correct. Yes. Good job. 2520. Nice. Okay, so there we go. So when you see this question in your final paper, you're not going to run away crying. Okay, look at that. You've already got 4 out of 7 marks. Okay, 4 out of 7 is great. You've passed, but obviously we want to try and do the best that we can. So let's finish this off and do the second question. Okay, so now it says to us, guys, how many unique 3-digit codes can be formed using the above digits if, now they're giving us a whole bunch of conditions. The digits may be repeated. The code is greater than 400 but less than 600. And the code is divisible by 5. Okay, so Christian, you've said 343. Where are you getting your 343 from? Where does that come from? Seven to the power of 3. Okay, that's not what I would have said for this one, Christian. Okay, what I would have done here, okay, so let's just get this down. Okay, we're going to fill 3 boxes, right? Because we want a 3-digit code. The numbers that we're allowed to use are, I'm just going to get them down. We are allowed to use 3, 4, 5, 6, 7, 8, or 9. Okay. So that is a choice of how many numbers. One, 2, 3, 4, 5, 6, 7 numbers. Okay. But even though the code, the digits may be repeated, the code has to be greater than 400 but less than 600. So in other words, what numbers can go into this first block? Can I put a 3 in this first block? Can I put a 3 in the first block? No. Okay, exactly, no. Can I put an 8 in the first block? No, all right. So the number has to be greater than 400, but less than 600. So does that mean that I could put a 6 in the first block?
Yes.
But if it's going to be less than 600, it's not including 600. Okay, so that means that I can't put a 6 into the first block. There are only 2 numbers that can go into the first block. What are they? Only 4 or 5. Does that make sense, Matric? Okay, so only 4 and 5. I only have 2 options for the first block. Okay, either the number 4 or the number 5. Now they've said to us that the code has to be divisible by 5. So let's consider the last block. The code has to be divisible by 5. So what are the rules for divisibility by 5? It has to end in 0 or 5. But is 0 one of the numbers that I have here? There's no 0. So the only number that it can possibly end in is 5. So as far as my last block is concerned, I only have one option, and that is 5. Right? The digits are allowed to be repeated. Okay, so I had 7 digits to start off with. I've used 2 of them, but it doesn't matter. So in the middle over here, how many digits are available for me to use? Because I'm allowed to repeat. Indeed, there you go. Okay, so 2 by 7 by 1. Okay, that would give us 14. Okay, and there we go. We've got 7 out of 7. I'm just trying to remember where this particular question came from, but I mean, it's also one of the recent papers. All the questions that I've picked have all come out of like either 2020, 2019 or 2018. So you can go there and have a look. So can you see, those of you who are feeling horrified and shattered after that question about the complement, it didn't even come up. All right, so it may come up, it may not, but at least then you've been able to see it over here. Let's just have a look at where they allocated the marks. Not that that would be difficult to work out. Yeah. All right, which is exactly what we said. Okay, I feel so sad. I was so much more that I wanted to do with you guys. I could sit here all night carrying on and on and on. But anyway, unfortunately, our 2 hours are up now. You guys have been amazing. Really, really, really amazing. Thank you so much for interacting with me and for providing answers and for telling me what you think. I've really enjoyed this lesson. But more importantly, I hope you really enjoyed the lesson, and I hope that it's been beneficial to you. Okay, are you feeling a little bit more confident about fundamental counting principle? You can give me a thumbs up or a thumbs down. How are you feeling now at the end? Thanks, Lindile. Thanks, guys. Okay. Cool, CP. Thanks, Atin Corsi. You guys are wonderful. Thank you so much. Okay, so yeah, I'm saying well done to you. Okay, you are getting there. You are getting there. So yeah, big claps. Well done. I'm very, very proud of you. Thank you so much for a wonderful lesson. You guys are great. Okay, so just keep practicing. Okay, we will have Q&A sessions closer to the time for when you write your final papers. So if you do come across a fundamental counting principle question that you don't understand, bring it along and we can have a look at it at a Q&A session. Okay. All right. Good luck, guys. Well done. Thanks for everything. I'm going to hand back to Coco now.
Thanks, ma'am.
Awesome. Thank you
Pleasure.
so much. That was lot and really great. Thank you so much, Lee. Hi, guys. I'm so glad to see so many of you guys with us. I'm glad to see so many new names. There are quite a few names that I've never seen before. So for those of you who are new, welcome. You're going to have so much fun with us here. Yes, Meloguhle, we will get to trigonometry. Do not worry. We're going to be going through all the things that are going to come up in your exam papers. I'm actually going to be sharing my screen now to show you guys what's actually coming up. So you'll be able to see what we'll be working through. Okay, so I'm going to share my screen quickly, and we're looking at the workshop. Oh, I think my screen is frozen. My goodness. Okay, there we go. All right, so what we've actually gone through now, and this is just when we're looking at the fundamental counting principle and bivariate data, which is what we did on Monday's lesson. These are the two that we're going to tackle in this section. Now, the next section that's coming, we're going to be looking at a couple other things. I'm going to be showing you guys what those are. But in order to just get an idea of what this is, we're going to be looking at some of the homework. We're going to go onto the app, click on topics, and we're going to look for statistics. And then we're going to scroll all the way down, and we're going to look for factorials and counting. It should be sitting under counting and factorials. Just look for factorials and counting. And you guys can try the quiz as well to just make sure you understand the concept a little bit more. Okay, but again, keep on practicing. We know that this is a really trying time for you guys, so just keep at it and you know, get as much practice in as you can before the exam. All right, so this is what our workshop schedule actually looks like. And we are on week 1 at the moment. So we're looking at Monday, we had stats and FCP. Today we had stats and FCP again. And on Saturday, from 10 a.m. to 1 p.m., we're going to be having the functions workshop, which is coming up. So I hope to see all of you guys there. 10 a.m. We will send you guys a Zoom link. It'll probably be the one that you have now that we're looking at. But all of this, I know it's a bit overwhelming, all of it is on our website. So if you go to watobe.co.za, you'll be able to see the entire schedule for what we'll be doing for this workshop. Okay, last thing, please invite all your friends. Tell your friends about Watobe, tell them about what we're doing. If you think there's somebody in your class or one of your friends who would benefit from getting all of this, please let them know and have them come and join us. And yeah, they can get as much knowledge as you guys are getting. I feel so much better about this section now. I feel like I could write my matric all over again. It's so great. Okay, thank you so much, guys, for joining us. We're gonna see you guys again on Saturday at 10 a.m. And yeah, that's it from us, guys. Okay, we'll see you again on Saturday. Bye, everyone.
Bye. Bye, ma'am.
Bye.
Okay.
Bye. Well done, everybody.
Bye.
Bye.
Bye, guys.